In this video, we'll solve the differential equation y times 1 plus x squared times dy is equal to dx, where y of 0 is equal to 2. Now, the first step we're going to do is bring the x's on one side and the y's on the other. So that involves dividing both sides by 1 plus x squared. Okay, on the left side then we have y dy is equal to dx over 1 plus x squared. Now we can integrate both sides. The antiderivative of y is y squared over 2, and then the antiderivative 1 over 1 plus x squared is the inverse tangent of x, and then we're going to add c at the end there. My goal is to solve for y, so let's multiply both sides by 2. If I multiply 2 by the constant, I get another constant. So I'm just going to call that c. And now I can take the square root of both sides. Okay, so the y is equal to the square root of 2 times inverse tangent of x plus c. Notice that I technically need a plus or minus because I have y squared equals something else like 2 inverse tangent plus c. Take the square root of both sides. There should be two answers because this is y squared. But because we have the initial condition that when x is 0, y is 2, I get that y is positive. But notice that if I have a negative here, this thing is going to be always positive, except one time it's going to be 0. So that if I have a negative here, that means the y has to be negative. So that means I have to eliminate the negative and leave the positive only. And now I can solve for c. So I just plug in x equals 0. And the inverse tangent of 0 is just 0. So really what I'm left with is square root of c, and that's going to equal 2. If I square both sides, I get c is 4. Now I'm just going to plug in c is 4 back into my solution and get that y is equal to the square root of 2 inverse tangent of x plus 4.